You know what is friction and how to find the value for friction. That's nothing but you have a surface and a body is placed above the surface. Now you are applying a force like this. So the friction will be acting in such a way that will try to oppose the relative motion. So friction force will be in this direction. Force. Now we know that frictional force is nothing but constant, that is nothing but coefficient of friction into the normal reaction. So now the object has placed on a surface, so this surface will be providing a reaction. So here what is the action? That is nothing but the weight of this object exerting a force. That is nothing but weight itself. Weight is equal to mg. So this object is basically exerting an action on the surface of the table. According to that, this will be providing a normal reaction. Now we know that this object neither moving downward nor moving upward. That means the normal reaction and mg is equal. Or I can say here in this case, only in this case, we can equate mg is equal to normal reaction. There are some other cases where mg is not equal to normal reaction. In this scenario, the mg is acted vertically downward. Always mg will be directed towards the center of the earth. Now this is the surface, correct? Then the normal reaction has to be calculated normal to that surface. So normal reaction will be this. In this scenario, you can split mg into two components. One is this, another one is this. So if this angle is theta, then this will be mg cos theta and this will be mg sin theta. Now I can say that this object is neither going upward nor going downward or in this direction along this line. That is due to the cancellation of mg cos theta by the normal reaction. So mg cos theta is equal to normal reaction. Whenever it is like this, see mg cos theta, what is the maximum value of cos theta? That is 1. So this will become maximum at mg cos theta become mg. So the maximum value of normal reaction is mg. And normal reaction can sometimes be 0 also. I'll tell you. If you are placing an object, if this is the wall, and if you are placing the object like this, then see mg will be acted downward and object is free to move having no connection with the surface. So basically this surface, the normal reaction is nothing but the reaction provided by the surface nor with a perpendicular direction or normal to the surface. Now here in this case normal reaction is 0, or I can say mg cos theta becomes 0 because cos theta is nothing but 90 degree. This is about frictional force. So we know how to find the frictional force. Frictional force is nothing but mu into normal reaction. So normal reaction will be varying from structure to structure or system to system. How the object is placed with respect to the surface. So this is the frictional force. I'll take the same example that I have drawn previously. Now we have the mass placed here. We know that this will obviously be coming down, but not with all the inclination. You have placed the object initially at here. It was not coming in this direction. Then you have inclined it. Still that has not came. Then again you have increased the angle and finally you have reached an angle. At that angle that has started coming down. This angle is called as angle of repose. The angle by which when a surface has been tilted, an object start moving by itself. So I'll see, obviously whenever there is a motion, there will be a force associated with it unless and until it is a uniform velocity motion. But here I mean like on the surface of earth, uniform velocity motion with no force is not possible because you have friction all the time. Anyway, we'll go back to that topic later. Here in this case, angle is theta, and we know the body will be acted by weight which is vertically downward. Now this weight will be having two components, one in this direction and one in this direction. This angle is theta. Why? Because this angle is theta. Now just assume the whole thing is a triangle, and if you are completing this as triangle, this will be 90, this will be 90 minus theta. If this is 90 minus theta, then the whole thing is 90, so this will become theta. So if this is theta, this angle is theta. If this is mg, this will be mg cos theta, and this is mg sin theta. Now you will come to know what force is driving the object towards along the slope, that is nothing but mg sin theta component. But the problem here is whenever there is a force that makes the relative motion, there will be a friction opposing that motion. Here the frictional force, we don't know, but we know the frictional, how to find the frictional force, that is nothing but mu into normal reaction. Now what is normal reaction? We know that normal reaction has been mg cos theta has been cancelled by normal reaction. That's the reason this is neither going upward nor going downward. That is only coming in this direction. That is, this comes due to the fact that this has become slightly more than this, or this driving force mg sin theta has overcame the frictional force. So anyway, here I can say that n is equal to mg cos theta. And here this is slightly more than this, that's the reason it is coming down. I will equate these two. The moment when this slightly become more than that, then that will come down. So now I will equate it. Mg sin theta is equal to mu into normal reaction. So I will do one thing. I have mg sin theta, mg cos theta here. This is second equation, this is first equation. I will rearrange it. This implies nothing but I will just swap in between. Mg cos theta is equal to normal reaction. Then second equation divided by first equation is nothing but mg sin theta by mg cos theta is equal to mu into n divided by n. mg cancels, sin theta by cos theta, tan theta is equal to normal reaction has cancelled, mu. This is an important derivation. We know theta is nothing but angle of repose. That is nothing but tan of angle of repose is equal to mu. Mu is nothing but coefficient of static friction. Here it will be static friction. I will tell you, because static friction is nothing but the friction just before it starts the motion. Basically static friction is the highest value, and I will explain it later. The kinetic friction is less compared to static friction. So we will take static friction because just to start motion we have to overcome the static friction. So this is nothing but tan of angle of friction is nothing but mus. Mus is nothing but coefficient of static friction. Now I will also this is angle of friction, angle of repose. Now I will explain angle of friction. Angle of friction is nothing but the same equation, same thing, same diagram. I'll draw it for a level surface so I will better understand this. You have the surface, then you have a mass here. You are applying a force in this direction, so obviously there will be a frictional force in this direction, and this mg is downward, so normal reaction upward. Why this frictional force has came? Due to the action force. So basically this is a reaction for the frictional force. At this scenario, so this is action, this is reaction, basically frictional force, because frictional force has came due to the applied force. In this case I can say that the result, this is again a reaction due to mg. Now this is a reaction due to frictional force. So these are two reactions. Now if I am taking the resultant of these two reactions, just draw the parallelogram. Then this is the reaction. Here in this case, the angle between this is resultant of reactions. Resultant of reactions. The angle between the resultant of reactions to the normal reaction. This angle is called as angle of friction. Angle of friction. Now see this, we will try to find what is angle of friction. What is tan theta from this triangle? From this triangle, that is nothing but opposite. Here opposite is nothing but this, that is nothing but frictional force, Fs. These two are same because these are parallel vectors now. Opposite by adjacent. What is adjacent? That is nothing but normal reaction. Now what is frictional force? We know frictional force is nothing but mu into normal reaction. Now I'll substitute this mu into normal reaction divided by normal reaction. These two will cancel. That will give you tan theta is equal to mu. This is another derivation. So tan of angle of friction and angle of repose both are equal to mu. Thank you.